Hi everyone, this is Moni Singh, and welcome back to our Teaching STEM podcast and the Facebook and YouTube series. We are continuing down the path of my very first STEM curriculum for children, civil engineering, and I'm going through and kind of talking a little bit about just bits and pieces from here from this curriculum, and I hope you're enjoying that journey. So we'll continue forward. And so far, we've talked about, showcasing the children what the career of civil engineering entail, because we always want to begin with the end in mind, showing them a real career, real opportunity. It's important that the child understands the so what, right? Whatever they're learning, they understand why, like gravity. If you teach children gravity, it's like, okay, just one concept, I don't care. But when you tell them, oh, this is where you see it in effect, or this is how it impacts you, they really understand, they grasp it quite a bit more, and they're more inclined to to learning those concepts. So like when we would do introduce gravity, we would actually have them jump up and down. I remember we were at that point very beginning when we began doing STEM. I started off in a church building, and they had chairs which had like almost purple cushions. I still remember that, and so we would have those chairs, and ask the children to just stand up, and then take their shoes off, and then go try to jump up on the chair, and then come back down, then jump back on the chair and back come back down. And then you'd ask them, okay, so which is easier, going up or down? And then of course going down is easier. And why is it easier, right? And it's easier because now there's something that's actually helping you. It's the force of gravity, right, that's actually helping you in that direction. So it was interesting. I mean, as we made all of this kind of this learning part of experiences. So they were actually experiencing things, experiencing gravity, as opposed to us teaching them, okay, this is gravity and a force that pulls. So anyhow, I wanted to continue down. And so here's something. The picture is really cute, so let me show that to you. So this is like a balloon, and then they have the shoes, booties, literally booties in the bottom of it. So we actually have like an activity and a little contraption that kids make using balloon and this little thing, the kind of the booty that you see. And we had a couple of different activities that the kids would do. The first one was, they take like we'd actually have them take a little piece of clay and put it inside the balloon. And then once it's inside a balloon, you kind of shape it into, like, make it a little round. And then you blow the balloon, so it's like and make sure it's like a see-through color so you can see inside. So there's a clay ball, a small clay ball inside the balloon, and now you have the balloon blown up. You actually fill air in it, and then you pass that, you throw that balloon around and have all the children kind of catch it and try to figure out what's happening. And of course the balloon is like wobbling. It's kind of, instead of going the way you'll expect the balloon to go, it's kind of wobbling through as you're throwing it around because of the clay inside. And you actually have the kids then think about, so what's really happening here, right? Why is it going in this kind of strange pattern? And one thing to know is that, when you have kids in balloon, it's always a lot of fun. And now you can translate that fun into something that kids can actually think about critically and figure out what's happening, why is it kind of going in this crazy pattern. So of course, it's because of the center of gravity of that contraption that we made. It actually is right where the center of gravity of that ball is. So as the ball is moving, that's where the balloon kind of almost follows along, even though the ball is inside the balloon. So that creates this kind of a completely rickety, rackety kind of movement, but it makes it a lot of fun for children. And so after that, as we were as we would introduce the concept of foundations, right? Because for any structure you have to have a strong foundation. We started off with this another contraption with a balloon, and like having a wooden base. and you take a balloon, blow it up, and then you can have face and stuff marked up on it, so almost like a face. And we used to call it Balloonia, and then kids could actually name their own Balloonias, whatever they wanted to. And they would have this attached to this wooden thing at the bottom, almost like a foot. And every time you throw this Balloonia up, it would always fall back down on its foot. And which is really interesting, because then you ask the kids, right, what's happening. um, and then you, before they even throw it once, you actually have them make a hypothesis, which is really important, because you have them think first, then you do, and then you reflect on what happened. So here it says that, blow up the balloon and tie it off. Draw a face with permanent marker on the balloon. Use a string to tie at the bar at the end of the balloon. Tie the end of the string to the wooden disc. So that's the base. Ask what the participants think will happen if you drop the balloon from above your head. So you're basically trying to drop it at this level. What do you think will happen? And first you get some predictions, right? So you do want the kids to think about it and make some predictions about it. And once they've made the predictions, that's when you then have them toss the balloon. And discuss what happened. Tell the participants that the balloon is always landing on its feet, or in this case, it's the wooden disc. And this is again because of that center of gravity, right? The center of gravity of that contraption is in the heavier part, which is that base, the wood. And so it always kind of comes down to that. And the same thing then applies to structures, building structures. They are built so that the center of gravity always come towards the point where then it can have a strong foundation. So introducing the topic of foundations by doing activities like this, again, it kind of keeps the kids involved, and they now experience something, as opposed to just hearing about the theory of strong foundations. So um, again, something to bear in mind as you think about your own classes and your activities that you might decide to do. I want to show this thing to you, because this I think is very powerful. The engineering design process. So one of the things that that's very important in this journey that you take the kids with you is to ensure that they are thinking, they are creating in a way that we call it the engineering process, right? It's like a iterative process. You put some thought into things. You're looking at a problem, right? You have a problem at hand. You think about what is that problem, what are the ways that you can solve that problem. Then you start to imagine solutions. You plan it out. You may draw some, like sketches, and plan out what materials you need to solve that problem, to create a solution for that problem. And then you go create. And then, of course, once you've created it, you measure the parameters that you are interested in. Make sure, does it fulfill the solution that you were looking for? Is it really solving that problem? And then finding a way to improve that. So that's a continuous cycle, right? Ask, imagine, plan, create, and then improve, and going back to ask, because it's a continuous cycle that goes on. So we encouraging the kids to think like that helps them a lot, because at the end of the day, in today's world, there's content everywhere, right? I mean, if you want to learn something, you do a quick Google search, and you have like tons of information that comes out. And kids can learn a lot about new things and the concepts they want to learn. But one of the important things, when they are in person, they're doing program activities with you. One of your main role becomes is to um, have them, encourage them to think about this problem solving, right? So it doesn't matter what problem comes their way, but they know they have a process on how they're going to tackle that, and they know how they're going to find answers, because they may not know all the answers, and that's okay, that's perfectly fine. But even knowing how you find those answers is it's a great skill to have. So that's something that you can definitely encourage as as you go into the STEM learning, this teaching STEM for your students. And I'll talk a little bit more about this engineering design process the next time we speak with an example, and that may make it a little bit more clear. So, with that, we will end this session and we'll come back next time. Thank you all, everyone. And if you're liking these discussions, please do go ahead and like them. Tell your friends about it. Encourage them to go like whatever channel you're on, and so we can keep at it. We can do more of this. All right. Thank you, everyone. Bye.